Dr. Gale Sinatra is the Stephen H. Crocker Chair and Professor of Psychology and Education at the Rossier School of Education at the University of Thousand, California. Prof. Sinatra heads the Motivated Change Research Lab at USC, the mission of which is understanding the cognitive, motivational, and emotional processes that lead to attitude change, conceptual change, and successful STEM learning. She is the past president of the American Psychological Association's Division 15, Educational Psychology. She's a fellow of both the APA and American Educational Research Association, and she's currently the chair of the APA Climate Change Task Force. Her forthcoming co-authored book with psychologist Dr. Barbara Hofer, entitled Science Denial, Why It Happens and What to Do About It, will be available in July at Oxford University Press. The title of her presentation today is Teaching and Learning About Climate Change, Challenges and Opportunities. And Dr. Sinatra would like to take the questions at the end of the talk. So we'll have about 45 minutes of presentation, and then we'll go on to the Q&A section. Welcome, Dr. Sinatra.
Merci bien, Alexis. Thank you very much for introducing me. I'm very, very excited to be here with you today. And I'm going to share my screen. Okay, again, are you ready for me? Yes?
Yeah. I was just confirming that your screen looks good. Excellent,
thank you. So very, very happy to be here with you today talking about teaching and learning about climate change, what I see as challenges and opportunities for us in education and psychology. So I'm going to start with public understanding of science in general, because that's the area of my current study and expertise in my book, and ask the question of why does it matter whether the public understands science or not? And I think this picture of the beach border in the United States in Florida, this about a year ago, tells you why it matters. There were two different stay-at-home policies right next to each other in these two counties in Florida, and you can see the difference it made in public policy and how that impacted people in their daily lives. And so I would argue this is a sort of a metaphor for why it does matter how the public views science and understands science. My interest in public understanding of science goes back to a conference I attended with my colleague, Barbara Hofer. We wrote a couple papers out of that conference, and this is the one that really started us thinking deeply about public understanding of science. It's in Policy Insights from Brain and Behavioral Sciences. And any of my papers that any student wants, you may write me if you can't get access to them, and I will obviously send you a copy. In this paper, we talk about some of the challenges for public understanding of science and what has to be done to enhance that understanding. And we said that you have to overcome misconceptions, and you have to understand the nature of science. You have to be able to weigh uncertainty in science, and what does that mean? You need to be able to examine who to trust in terms of getting your information about science. You need to be able to evaluate competing knowledge claims about a scientific issue. You need to leverage motivations, emotions, and conflicting beliefs. And you need to support positive attitudes. And I'm going to discuss most of these issues in this talk today. These issues went on to inform our book, and here it is. We're very excited about it. It's called Science Denial, Why It Happens and What to Do About It. This is my colleague, Barbara Hofer, who is a collaborator on this project. It's published by Oxford University Press. It's available for pre-order if you are interested, from Amazon and directly from the Oxford University Press website. But in this book, what we do is we take the issues in that article that I just had on the previous slide, And we delve into them, of course, more deeply in terms of almost a chapter on each of those issues. What we think is unique about this book and why I'm referencing it for you is whether it'll be useful for you is because what we drill down on here about, and this, I was just sort of peeking into the last presentation and heard this come out in the last presentation, is we kind of know what the problems are now, but what do we do about it? And that's really a big factor in this book. So what we do is we have each of these problems identified and we discuss them and we talk in each chapter about ways to address the problem. And then we have an entire chapter at the end concluding, summarizing all those things together. So I'll talk about some of that today as it pertains to public understanding of science in general and the challenges and solutions to public understanding of climate change in particular. Okay, so what are those? Well, some of those we've already mentioned, so I'm going to go through a bunch that I won't be able to have time to talk about today, but I'm going to talk about several of these. So I mentioned misconceptions. Well, what can we do about that? My work is in conceptual change, rooted in overcoming misconceptions. So I'll directly speak on that today. We have climate denial. One way to help with that is debunking misconceptions. And I know last week, and I attended some of the great debunking talks that you had from Stephen Lewandowski and others last week. One thing I don't know that you've heard a lot about in the last 2 weeks of classwork here is thinking and reasoning about the nature of science itself. And we're going to talk about that here today, about epistemic cognition, which is thinking about the nature of knowledge itself, particularly the nature of scientific knowledge, and teaching those epistemic practices, having students engage in those, and that will be something we will talk about today. We have a lot of mistrust. You've seen that in the pandemic more broadly with mistrust of the science on mask wearing and social distancing, and of course, vaccine hesitance. We have a large problem with epistemic trust, knowing who to trust regarding what types of knowledge. Won't be discussing that today because we can't get everything in. We know that a lot of this information is conveyed online, and that's where really most Americans find their scientific knowledge, unfortunately. And online, you're well aware, there's a slew of mis and disinformation that is pervade. And so what could you do about that? You can teach better sourcing. I will talk about that directly today. We don't understand, we citizens don't understand uncertainty very well, probabilistic thinking very well. When you think about climate modeling, it's based on stochastic reasoning and probability. There's a lot of reason to believe that people can be taught this reasoning and that it will help them. I just had a student do a dissertation on that. Not talking about that today, but I can refer you to his work if this is an area of your interest. Few more. Complexity. Climate change is complex. It requires systems thinking, and we know it's difficult to teach systems thinking. Won't be talking about that today, but it's an area that needs research. Negative emotions. We'll be talking about emotions today. What can you do about negative emotions? We have successfully addressed negative emotions. I have lots of ideas about that. You need to tamp down negative emotions because, as you probably understand, these issues are very evocative emotionally, and people will push back against them based on their emotional responses to climate change. And this is people who accept climate change as well as those who struggle to accept climate change. If you understand what's happening, you probably have some negative emotions such as anxiety and fear. Motivated reasoning, we go into that in great depth in the book. You've heard a lot about that. What we would say is being reflective about your own reasoning, because we can fall prey to scientific misconceptions just as easily as members of the general public. So we advocate that. In-group, out-group identity from social psychology. We know that people are listening to their in-groups about, say, vaccination hesitancy and vaccination safety or mask wearing in the United States, which was hugely politicized by in-group politics. We know you can shift in-group membership. I will give you a demonstration of how we did that with a conservation message, sustainability conservation message today. Climate anxiety is real. I'm, as mentioned in our introduction, chairing the American Psychological Association Climate Change Task Force, and our clinicians and counselors on the task force are deeply concerned about the degree of climate anxiety, particularly among youth. One of the things that we're talking about there is becoming involved in climate advocacy, and taking climate action can really help reduce anxiety as you feel more empowered and you feel like you are moving in a more positive direction. So we advocate that. Won't be talking about that today, but I'm happy to discuss it in question period. And then social injustice is deeply rooted in the causes of climate change to begin with, the denial of climate change that ongoes in political discourse, and the resistance to climate action that has been going on for decades, and taking an environmental social justice stance is definitely something we are seeing really coming together. The social justice movement is coming together with the climate justice movement, and this is an extremely positive direction. And again, I won't talk about any research on that, but I will talk about it in our question and answer period at the end. All right, so then going through some examples from each of the things that I mentioned on those lists that I have time to talk about today. And I want to start with misconceptions because we've done a ton of work on that. Some of the common misconceptions we've seen are, well, humans can't impact the climate, so why bother? The climate is always changing, so it's just a natural process, so don't worry about it. Oh, this is just air pollution. It's not really going to affect the climate. It's just pollution that you see in dust and dirt and smog in the air, particularly where I live in Los Angeles. Oh, sure, there's warming, but it's due to increased solar radiation. So you can't control that, so don't worry about it. There's just this hole in the ozone, and that's what's causing climate change. There's no scientific consensus on climate change because scientists don't agree. And one of my favorites is, oh, there's been a period of cooling recently, so climate change is over. So this is by no means the full list of misconceptions we've explored. There's many, many more, but we have looked at these. Well, what can you do to fight misconceptions? Well, I'd like to talk about my model of conceptual change, which does become very useful to us in our research in confronting misconceptions and promoting a change in conceptual understanding about constructs like climate change. So this is called the CRKM, the Cognitive Reconstruction of Knowledge Model. It is a dated model, but we still find it very, very useful. And so it looks at the interaction between learners' conceptions, what they originally come to the learning experience with, and the message they are receiving in texts or in their classroom or over the internet. And it looks at the interaction between the learner's existing conception and how strong, coherent it is and committed they are to it. So if they have a strength of that knowledge, they know a lot about it, it's coherent, psychologically coherent, meaning connected to a lot of other knowledge, and they might be deeply committed to it, that is going to be a struggle for change. What about motivational factors? We look at many not listed on the model, and I'll show you that, but we've looked at specifically things like personal relevance, the social context that they are motivated to be a part, personal identity comes in there, Dissatisfaction, this is almost a Piagetian notion, dissatisfaction with your current conception leads to a motivation to resolve that dissatisfaction. Need for cognition, it's a dispositional factor that can motivate individuals towards change. Those are only a few examples. There's many, many more. These characteristics of the learner interact with characteristics of the message. We look at issues like comprehensibility. Obviously, you can't understand a climate change message if you don't understand what CO2 is, can't understand what the greenhouse effect is. Coherence is obviously an important factor in that. How coherent is the message? We've done a lot of work on plausibility, and I'll share that today. And then there's just the rhetorically compelling nature of messages. Some messages resonate more with people than others, and that's really important for message framing. We'll talk about framing a little bit today, and I know you've had some talks on framing last week with some of your other presenters. So these characteristics interact to form a degree of engagement. A learner is either resistant or semi-open to change, and then has to interact with this message and either will understand it or not, or find it compelling or plausible or not. And if they interact with this message on a high degree of engagement, which we call metacognitive engagement, thinking deeply about the issues, weighing the pluses and minuses, then you have a probability of conceptual change. But if they don't engage deeply, if they're dismissive of the message, if they won't think about the opposite side, they won't weigh the alternative, they won't think about it, you're not going to get any change. Or if you do, you'll get weak change and it will just not persist. So that's a brief overview of the main points of the model, and I'll take questions about it, of course, at the end. And so, as I said, we've been researching this model for a long time. And after it was proposed, we did about 10 years of research on the model. And we did look at many other motivations, what we called warm change factors. We looked at values. You just had a long talk about values. That's very important. Goals. We look at learning goals, personal goals, beliefs. We look at epistemic beliefs, beliefs about the nature of knowledge and knowing, political beliefs, misconceived beliefs. We look at self-efficacy. That's an important factor in your likelihood of change. Interested emotions, we've looked at extensively. The role of those, if you're interested in something, you're more likely to engage. If you have negative emotions, you're less likely to change your thinking or even engage in the first place. Epistemic motives, we've looked at things like need for cognition and a disposition towards open-minded thinking, need for closure. There's a lot of dispositional epistemic motives. We've looked at all of those in relation to 3 topics in particular, many topics, but obviously climate change, but we've also looked at it in terms of evolution and GMOs, genetically modified organisms that we eat for food, which is a very science-resistant topic in Southern California, where I live. But my model there is only about knowledge. But when you talk about warm change, bringing in these affective and motivational constructs, you really have to look at attitudes. So you probably know that attitudes are valenced evaluations. They're either pro or con. And so Vivian Saranian, a social psychologist, and I proposed this 2x2 framework resulting in 4 learner profiles. And it's the idea is to look at how does someone's knowledge interact with their attitudes, and are they linked, and is this important to consider in conceptual change and changing people's ideas about scientific topics? And we say it is. So if you look at this, we say that you can have a conception and it can be either accurate or inaccurate. And by accurate and inaccurate, we mean how well is it aligned with scientific point of view. And then you can have an attitude, and the attitude can either be pro or con. This results in these 4 profiles. So I'll start by looking at this first profile, accurate, pro. So you can have an accurate concept of climate change. You actually know what the mechanism is that causes climate change, and you can accept humans' role in climate change, and you are pro climate action, climate policy, climate mitigation strategies. You're all set. We don't need to worry too much about you. Then over here, you can have an inaccurate conception and ironically still be pro. So how does that look? Well, you can be in favor of climate mitigation strategies to reduce pollution like dust and dirt and litter. This is actually a misconception some people have, that that's climate change. But of course, air pollution itself is not climate change, it's CO2, which of course contributes to polluted air, but it's specifically the CO2. It's not dust and dirt. I used to live in Las Vegas. There's a lot of dust in the air. That is not causing climate change. But you might see that. You might see dust clouds and you might think, yeah, boy, we need to clean up the air because of climate change. And you'd be in favor of climate action. So you might say, well, why worry about these folks? They're on the right track attitudinally. Well, of course, you can't enact accurate policy and accurate guidance for the wrong reason, because you could, of course, end up doing the wrong things. Like supporting reduction of dust is not going to help climate change. All right, so then you can have an accurate understanding, but be con or negative in your attitude. So maybe you understand climate change quite well, but you say, oh, it's too big a problem. It's too difficult. It'll be too expensive. It's not going to work. These mitigative strategies won't work. We can't convert to electric cars. There's no charging stations. It's too expensive. I still like my truck. So you're against it, even though you understand it. And then there's this last category. And this is what my students like to call low-hanging fruit, because these are the people who are most malleable to change, we believe. And these are people who have inaccurate ideas and misconceptions, and they're negative in their attitude. So they won't take climate action because they have a misunderstanding of what that means. We have noticed these people being the most malleable if we can upend their misconceptions. Because if we can do that, we see shifts in their climate acceptance. Okay, so again, why does all this matter? Well, because democracies need educated citizens to make informed decisions about their health, their well-being, their community, their nation, their planet. I think this was no more well illustrated than in 2020 when we experienced the global pandemic. These issues obviously include broader issues than climate change, vaccination, climate change, fracking, stem cell research, GMOs. We've explored all of these in our research program. So one thing to understand, though, is the challenge of evaluating and understanding these scientific claims shows that there's this disconnect between what scientists think about these issues, climate change and these other scientific issues, and what the general public thinks about these issues. So when you look at science communication, particularly in the US, I'm hoping it's better in Canada, you get this balanced reporting where all the reporters feel they must put on two people, one saying one thing and one saying the other, and they create this false equivalency that climate change is a 50-50 debate, and it gives disproportionate visibility to climate denialists and leads to what Oreskes, who presented to your group last week, calls manufactured doubt. You're creating this sense that, oh, well, it could be this, it could be that, climate change could be bad, it could be fine. You know, we should do something about it, we can't do anything about it. and it's a 50-50 debate, and that creates more doubt than is really there in the scientific community about humans' impact on climate change. And you can see this, you don't need to read this, but you can just see visually with the colors that when you have 97% agreement among the scientific community about the fundamental root causes of global warming, climate change, but the media coverage reflects a very different balance. What does the public perception reflect? It unfortunately reflects the media coverage, not the scientific coverage. And so that's why the media portrayal of climate change is so devastating to scientific acceptance of the public's general acceptance of scientific views of climate change. So what can you do about that? This isn't supposed to be a talk on education. You can help students make sense of scientific claims in this digital world. Science denial is not really a new thing. It goes back millennia. But today it's amplified through social media because of the spread of mis and disinformation. So I have an article with Doug Lombardi out in 2020 through the educational publication, The Educational Psychologist, that talks about online sourcing and how difficult it can be sourcing the source of information for science, and how challenging it is for students to source information correctly. I'm talking about K through 12 and higher education. If you ask students if young students, elementary school students have a question about whether humans and dinosaurs existed at the same time, a lot of times teachers ask their students to Google things. And if they Google that, they'll see evidence that they were contemporaries. So they get drawn to or led to misinformation about science online. So how do individuals decide what knowledge is accepted as valid? How do they evaluate scientific sources of information? Can you teach sourcing? Unfortunately, people are much more likely to believe scientific articles shared on Facebook than they are to believe a scientist, him or herself. We all live in social media bubbles, and we know there's a trust erosion, particularly erosion of trust in scientific expertise. And in our article, we go through how can you teach sourcing? And we are by no means the only people who've done this excellent work on sourcing by many scholars we cite in this article. So I encourage you to look at their original work. This is a review article. How do people learn about science? They just Google it. So what's the first thing to do when you Google something that's scientific and to teach students to do? Stop, step back, be vigilant. We often just share something we've read online because we think it's interesting or even funny if we don't think it's true, and that's bad. Don't do that. Encourage your students not to do that. Stop, step back, be vigilant, and say, follow sourcing best practices, which means becoming your own fact checker. There are strategies for fact checking that are very well worn that help. For example, reading laterally. If you don't know what that is, I'll tell you about that later. But it basically means opening up more windows and checking other sources of information about this. Then you have to evaluate the connection between evidence sources and alternative claims. This is really important. It's not just evaluating the evidence for the claim. You look to evidence for the alternative as well. That's a very strong scientific practice that we need to employ in our source evaluations. What Doug and I bring to it is, remember, plausibility from the model I showed you earlier. You have to reappraise your plausibility judgment about the claim. I'm going to show you a lot about what that means in a bit. Then come to a tentative judgment. So still not sharing, tentative judgment. And then after you've fully verified is the time to share. So click and share, not good. Taking these steps, better. Teaching people to do these steps, hard to do because we all want to click and share, but these are steps that we've been seeing in the literature can be very effective for improved source evaluation. Okay, if it were just one thing we needed to do, but it's not one thing. It's at least 3 things at all times that we need to do to understand controversial scientific issues and support students and the general public's understanding of them. We call this the hat trick of change. I know I can use this with a Canadian audience because you know what a hat trick is. Not all Americans understand that, but it's doing 3 things that is difficult to do all at the same time. And what are the 3 things that are difficult to do? Overcome misconceptions about innocuous topics. So it's really difficult to overcome misconceptions about emotionally evocative, controversial topics. Attitudinal shift or emotional shift. And I group these together because we see in our research they move together. I talked about attitudinal valence, pro and con. Emotional valence, positive and negative, is linked to attitudinal valence. We see this in our work all the time. In other words, if you have a negative attitude, you have negative emotions. And if you have positive attitudes, you have positive emotions, we see them linked. And then we think you have to promote epistemic conceptual change, which means you really have to promote a change in students' thinking about the nature of knowledge and the nature of science itself. And we have a lot of work to discuss on that. How do we do it? Well, we've done some extensive work on overcoming misconceptions about scientific concepts through refutation text. A refutation text involves stating a misconception directly, refuting that misconception directly, providing an explanation of the correct scientifically valid position. So for example, you might say some people believe changes in average global temperature are just natural. However, this is not correct. Scientists believe, and then you go on to state the correct explanation of humans' involvement in climate change. What we know from a vast amount of research we and others have done on this is that refutation texts can not only change knowledge, overcome misconceptions, but they can shift attitudes and emotions. We've done it with climate change. We've done it with other topics. There are hundreds and hundreds of these studies, and I'm currently conducting, along with my colleagues, an NSF-funded meta-analysis of refutation texts to see when they're effective and how effective they are. Here's an example of the kinds of texts we've used in different studies on the greenhouse effect, for example. This refutation text on the greenhouse effect has been used in many studies by ourselves and by colleagues, and it has resulted in a decrease in misconceptions about the greenhouse effect. What we've done is we've also explored, can you enhance the effectiveness of a refutation text by including in there more information than textual information, for example, graphical information? And the answer is yes, graphical information can help. Can you include analogies and metaphors? Yes, analogies can help. In this particular study, we included an analogy about being in a car in the summer where you roll up the windows and of course the car would get hot, and tried to use that as an analogy for the greenhouse effect. We also included in many studies, particularly this one and others, the famous hockey stick graph, which is the graph that depicts the change in CO2 over time and temperature over time. In addition to refutation texts that include this refutation, you can include persuasive communications, persuasive textual information. We've done that many times. This particular study, Sinatra et al. 2012, was with college students who read a persuasive text on climate change. We measured their attitudes. And in this study, we measured their willingness to take mitigative actions to reduce their climate impact. And while it was just a willingness scale, it wasn't actual actions, we saw that students did become more, students who were more open to change, dispositionally open to change, they were more willing to engage in these mitigative actions. So if you were open to change and you were willing to think deeply, we found that that predicted attitude change and expressed willingness to take action after reading this persuasive text. In this study by Krista Muse and myself and colleagues back in 2015, we looked at emotions related to climate change text-based messages. And what we found here is that when you read conflicting messages about climate change, that really is evocative of a lot of emotions. Conflicting information is not great. What do people read online? They read conflicting information all the time. But in this study, we found that students who had a belief in the justification of knowledge required critical evaluation and sourcing, they were willing to do the work to resolve these conflicting textual informations they were receiving. They reported enjoyment and curiosity. In other words, okay, I'm into this debate, I'll do the work and I'm willing to do it. But those students who believed that there's a lot of uncertainty around climate change, their reaction to these conflicting texts were confusion and anxiety. It just created a worse situation for them, or they just were bored with it. Probably too hard for you to read these correlational patterns here in this path analysis, but you can see it in the Muse et al. Study. And then finally, what we've done is we've paired the two elements, refutations with persuasive communication. And we've done it with climate change and with GMFs, genetically modified foods. And I'm going to share this one on GMFs, even though we're talking about climate change, because this one I think is really illustrative of what I'm saying. And I believe it plays out the same way as far as we can see from our research. In this study, just published last year, 2019, I mean, we paired a refutation text with persuasive information. So these persuasive informations, we were trying to persuade them in both directions, just to see exactly how that would go. And we emphasized both pros and cons. This was done with undergraduates in 3 countries. This was a Canadian sample. Krista Muse is at McGill, right near you. And in Germany, with our colleague Reinhard Peckren, and here in the US in LA. And we measure knowledge, attitudes, and epistemic emotions pre and post reading these texts. And the texts were the pro text compared to the context, compared to a text that included both pro and con information. Again, this was GMFs, not climate change, but the point is the same. What we find in this study is that the both texts is okay, but the pro text is the best one. These are modest effects, but they shifted attitudes and knowledge. And so what we would say in looking at climate change communications, if you're going to use rough text, if you're going to use persuasive text, great, but make it pro-positive attitudinal information, pro-persuasive information, including a lot of negatives and a lot of cons is not helpful. It just is confusing and frustrating for students and results in less learning. All right, so you might say, well, what about backfire effects? Because we've heard all about backfire effects. Well, you had Lewandowski on last week, who defines backfire as the ironic strengthening or intensification of original belief in misinformation, subject to an attempted correction. And in the 2020 handbook, debunking handbook, they came to the conclusion that backfire effects aren't as bad as originally thought. So we did a study, Jacobson and my colleagues, that's in press now, on backfire effects, again with GMFs, but we found the same thing, that the refutation texts work. And this was a study where we examined the structure of the explanation we provided, didn't make an effect, but our intuition is that more explanation is good as long as it's not too complex. But the main point of this study was to look at backfire effects. And again, there's a small backfire effect. So we don't think that backfire is worth that much worrying about. The debunking handbook has basically backed off their concern regarding backfire effects, and for something very important like vaccination information with the pandemic or climate change, a small amount of backfire is probably mitigated by the positive effect you get from giving these refutation and persuasive textual information. All right, I'm going to move to a different topic that we identify in the book and in our work regarding controversial science topic learning, and that's social identity. We know that group membership influences views of science. We know that individuals conform to the attitudes, norms, and in-group behavior of their group. In-group messages we know are far more persuasive than out-group messaging. And we know that sense of self and identity is tied into that group membership. We know from, for example, that with the pandemic, that identifying with a mother's group that has vaccination hesitancy means people will be more likely to be vaccine hesitant. We know that conservatives who were resisting mask wearing during the pandemic were influential in people's resistance to mask wearing. So we know this works for climate change as well as these topics. So what do you do about that? Well, in a study with Vivian Suranian, we used social identity framing communications about water conservation to shift not only in-group identification, but actual behavior. We actually measured water consumption and showed an impact. So for what we did here is we compared in-group messaging, which is more persuasive. So we wanted to use that to other types of messaging. So how do you shift someone's in-group? Typical communications on conservation and electricity use, water usage, these are usually done through social norms. So I don't know if you get these in Canada on your bills, but you get, oh, you consumed more water than your neighbor, or less water than your neighbor, or more electricity, less electricity. This is kind of a sort of a knowledge deficit view. In other words, you just don't know how much you're consuming, so give people these norms. But it turns out for high consumers, this knowledge deficit view does backfire and results in greater consumption, particularly if you look at your neighbor and find out that they're consuming more than you are. You're not likely to consume less, you're likely to consume more. Like, hey, I'm taking 5-minute showers and Joe across the street is using more than me. I might just consume more. So what we did instead was we shifted their social identity by saying, we can use social identity frames that identify you as a member of a different group. So what we said was, we, Southern Californians, we conserve water. And so then when you get people to identify not as a high water consumer, not as a person who has a great lawn that you need to water, but as a Southern Californian who conserves water, and you shift that identity group by using this we language, we conserve water, we Southern Californians. Well, we did this, we measured water consumption, actual water consumption, and we got an impact of social identity framing. And it was a better impact than the knowledge deficit view, which actually did backfire on us. Okay, new topic. What about thinking and reasoning biases? Yes, they're a problem. Reliance on system 1 versus system 2 processing means you're less deliberative, you're more likely to share misinformation, you're more likely to come to a favored conclusion. Confirmation bias, availability, heuristic, my side bias. We have a whole chapter in the book about all these biases. Here's an example of a US senator from the great state of Oklahoma in the United States, which is a very oil extraction rich state, bringing a snowball onto the US Senate floor and saying that climate change is over because it snowed. Obviously a availability heuristic bias, or maybe a confirmation bias. You could look at it either way. Well, what do you do about thinking and reasoning in general, not just biases? What do you do about the challenges of thinking and reasoning in climate change education? Well, this is a really great area of work done by my colleague, Doug Lombardi. Drawing on my colleague Barbara Hofer's work on epistemic cognition, which is how individuals think and reason about knowledge and knowing, and how to apply that knowledge. Like, what is knowledge? How do we know? Where do we get knowledge? How do we weigh competing truth claims and decide what authorities to trust? This influences science understanding. This is Doug Lombardi's plausibility judgment model. Remember, I said plausibility was going to come back to be very important in our work. I'm not going to go through the model in the interest of time. You can read the paper if you're interested, but people make these preliminary judgments, these snap judgments, and then they can make a plausibility evaluation. And you can get people to reevaluate their plausibility evaluation. And I'm going to show you how to do that. So I'm going to skip over the model and go right to how he does that. In this particular study, we didn't manipulate it. We just measured it. I'll show you the full study in a minute where we did teach it. This was a study about a misconception about weather-climate distinction, where we first looked at plausibility. We measured undergraduates in the climate change class, understanding of the weather-climate distinction, understanding of deep time, and this is where we first measured plausibility perceptions of human-induced climate change. How plausible did you think it was that people could impact the climate? And we saw that greater knowledge of deep time, that's millennial time, and higher plausibility perceptions predicted their understanding of the weather-climate distinction, and overall the course improved their understanding of the weather-climate distinction. So from there, we went to this study with kids. So how do you get people to reappraise their plausibility judgments? So you do critical evaluation, because critical evaluation promotes a higher quality plausibility judgment. What does that mean? Coordinate theory and evidence in a controlled and reflective and conscious manner. Going all the way back to my conceptual change model I presented at the beginning, this involves high metacognitive engagement. You really have to think deeply. How do you do it? We did this in a middle school with earth science students. This was in a very diverse area. We had 7 classes do this treatment, 7 control classes, both taught by their regular teachers. We pre-tested kids. We compared the traditional curriculum of answering questions about climate change evidence and making predictions to this climate change model evidence link diagram. Show you that. That's the instruction that promoted this critical evaluation. Then we post-tested them. What is the model evidence link diagram? What you do is you present students with two models. Model A is the scientific model. Model B is the skeptic model, the non-scientific model, the science denier model in a sense. And then you present 4 pieces of evidence, and then you ask students to evaluate each piece of evidence against each model. So they can say it supports or strongly supports model A or B. They can say it contradicts model A or B. They can say it has nothing to do with the model, but they have to basically draw these 8 arrows and determine the relationship between each piece of evidence and each model. Then we ask them to make these plausibility judgments. Which model is more plausible? Which model is more correct from a scientific standpoint? What we see is from pre to post, we get a big boost in plausibility judgments and model correctness evaluations. So students who receive this model evidence link diagram and have to coordinate theory and evidence shift from pre to post in their plausibility judgments. They think human-induced climate change is more plausible, and they think the human-induced climate change model is more correct. We also reduce their misconceptions. So some of the students in the treatment model increase in their evaluation that humans are causing climate change and decrease in their evaluation that it is these skeptic ideas like sun's increased solar radiation or orbital changes in the Earth's rotation or dust, as we mentioned before. Those are skeptic models. We reduce acceptance of skeptic models and increased acceptance of human-induced climate change. My colleague Doug Lombardi, who's doing this work, has done dozens of these studies with hundreds of kids since then, not only on climate change, but on fracking and other scientific topics. And this model evidence link evaluation works really effectively to teach this content. All right, moving to emotions. How am I doing on time? I think I'm okay.
I just want to let you know, yeah, in a few minutes, we're going to switch to the Q&A. So I'll let you,
So what do I have, 10 minutes or a little less?
Yeah, a little less if possible.
Okay,
Thank you.
I can go through this part really quickly. We have emotions about human-induced climate change, and this study points out that not only is it the general public, but it's teachers. Teachers share emotions about human-induced climate change. And in this study, teachers who were angry about it, either because they accepted it and either because they did not accept it, and so they were angry about climate change policy, or because they did accept it and they were feeling hopeless about it. So negative emotions from teachers can impact their teaching. Here's a skeptic teacher. She says, if you remember the ClimateGate scandal, it was some misinformation that was released by scientists by mistake, and it turned out to be this huge scandal because it was said to be deliberate, which it was not. She said, oh, you scientists, you lied about it. You've discredited yourself. Now how am I supposed to believe you when you come out with another statement? Are you lying again? This is a teacher. So what's the probability this teacher is going to be an effective instructor about climate change? Not good. All right, so we need to improve science literacy. The next generation science standards in the US is something we're advocating that teaches about the origins, production, and validation of scientific knowledge. We've done that ourselves using these refutation texts, confronted misconceptions about uncertainty because people feel like climate models are uncertain. That means scientists don't know what they're doing. we've been able to effectively confront that misconception using our refutation text paradigm. And then finally, I'll close with the current work that I'm doing. This is the La Brea Tar Pits and Museum in Los Angeles, where we are using augmented reality to teach about climate change and its impact on environment through this AR experience. And the reason why this is important is it's a place-based situation where La Brea Tar Pits gets massive visitors, kids on field trips, and it's where they live. And so instruction should be capitalizing on this place-based notion that students learn about and care about where they live and the impacts of climate change on their community. This is a 3-year project. We're testing all sorts of aspects of it, which I'll skip over. But what they do is they are able to see what's happening in these asphalt seeps where they discover fossils and they learn the impact of climate in Los Angeles and how it's changed over time and how it's changing. We have been able to increase their scientific knowledge, increase their interest. We've been able to increase positive emotions. This is so far with adults, not with children. We have a new grant we're pursuing to do it with kids. This is our little low poly animal. I'd love to show you what it looks like during their actual visualization embedded over the environment. So this kind of engaging science instruction, evocative, is what you need to move the needle on climate change understanding. So I'm going to conclude by whipping through these just 1 second at a time. The book concludes with actions. I promised you that there's steps you can take. So there's steps individuals can take, like being critical, thinking critically, improving your search strategies. There's steps educators can take, which is improving their own understanding of science. As we saw, teachers don't necessarily understand or are skeptic. And then they can foster this in their students. Policymakers need to really make changes. We go into that in the book about funding research and funding research on science learning, not just on science. Science communicators often do a good job, but often promote misconceptions, having this both sides bias or these terrible clickbait headlines you read.
I really want to thank you, Dr. Sinatra. That was a fascinating talk to conclude our day today. Thanks for being with us.
Thank you very much. I want to encourage you all to reach out to me if you have any questions about any of the articles I shared. And if you can't find them or don't have access to them on your libraries, please let me know. I'm happy to share any of those. I think you have my slides. You're welcome to rewatch the recording and keep up the good fight. I believe very, very strongly we need more psychologists involved in taking climate action. As you saw from your previous presenter, scientists aren't necessarily equipped to do this themselves. They need our help.
Thank you very much.